Okay, a triangle has vertices 0, 1, negative 1, 3, 3, and then, no, 0, 1 is here. 0, 1. B, and then C is 1, 2. 1, 2 is somewhere here. So that's the triangle. Okay, what is angle A? And the second question is, what is the area of the triangle? So, first thing to do is to come up with these two vectors. Since I want this angle, this is the question. Let's make this side as u, this side as v. Okay, so you invent two vectors so that the question now becomes, what's the angle between the two vectors? That's something that we just did, right? So what is the vector u? Vector u is, you always do terminal minus initial, so it's b minus a, which is negative 1, 3 minus 0, 1, so that this is negative 1, 2. Vector b is the vector that starts from A and ends at C, terminal minus initial, so that's going to be 1, 2 minus 0, 1, which is equal to 1, 1. Now you apply the formula. Cosine of the angle between is u dot v over norm of u, norm of v. And the dot product between the two are component-wise multiplication, and you add. So that's the dot product. And the norm of any vector is square root of the sum of the components, right? So component squares, sum of the squares of the components. So that it's going to be negative 1 plus 2 is 1. This will be square root of 5. This will be square root of 2. So that's going to be square root of 10. Okay, so that tells us the angle is cosine inverse of 1 over square root of 10. And the question says leave it as cosine inverse form. So just leave it like that, okay? B, what is the area of a triangle? Well, there are two ways to go about doing this. One is to use the following formula that some of you may know. If you have this length as A and that length as B and there's angle theta, the area of the triangle is 1/2 AB sine theta. How many of you seen this formula? So, okay. So if you took some trig class, you've seen this. So this is something that you can use because you know that the length of the one vector is square root of 5, the other one is square root of 2. And you know the cosine theta, and sine theta is simply, because sine squared plus cosine squared is 1, sine theta is 1 minus cosine squared theta. So using this, you have all the information that you need in order to calculate it. Yeah. But the one that we used in class wasn't this direction. The way I explained it in class is to think of these vectors as embedded in 3D, and you take the cross product of them. Now, why would you want to do the cross product? Because cross product has this, it gives you a vector whose magnitude is, the cross product has the magnitude being the area of the parallelogram, right? So what's happening is that if you take, so think of this vector as it's negative 1, 2, but think of it embedded in 3D, negative 1, 2, 0. And think of this one as embedded in 3D as 1, 1, 0. Then Taking the cross product of u cross b, actually, if you do it this way, it's actually going to go into the board. So probably I'm going to get a negative value, but that doesn't matter. Anyways, that vector is going to have the magnitude as the area of the parallelogram given by these two vectors, right? So all you have to do after that is just cut that in half, and then you get the area of the parallelogram. Okay? So let's do that. We're going to calculate the cross product of u and v, which is cross product is computed like this. And then you put in negative 1, 2, 0, 1, 1, no, is it? Yeah, 1, 1, 0. Okay.
I have a question.
Yes.
All the tests,
Yeah.
after with that, where's it 5 if I just wrote u cross product v equals negative 1, 2, 1, 1.
Yeah, if you know some shortcuts, it's fine.
Okay.
Yeah. So the easiest way to calculate this is not the usual way, expanding it this way, but you want to expand in this way. That's because you have, this is non-zero, but these are zeros, right? If you have lots of zeros, then you don't have to compute them, so that's the easiest way. Okay? So if you do that, then look, k, again, if you check the checkerboard of signs, it's plus, minus, plus, so k is still positive. But then the minor matrix is just this much, right? So that was the question that I just received. Can I just go from here to there directly? And the answer is yes. Yeah. If you happen to start with a two-dimensional vector, it just this is all you need. You just get the determinant. That's all you get. Okay? And since the other ones are zero, we don't care. Minus 0, plus 0, something, we don't care. Okay? It's just this. And sure enough, we get a negative 3. But what's the norm? Well, norm is just simply, well, okay. What's the length of k?
1,
1. So if you multiply by 3, what's the new length?
3,
3. If you multiply by negative 1, what's the new length?
negative 3.
No, it's positive 3. Length is always positive. It just changes the direction to the opposite, right? Okay. So this still has length 3. Of course, you can think of this as 0, 0, negative 3, and then put it inside the square root of 0 squared plus 0 squared plus negative 3 squared. But that's a waste of time. You can just right away see that obviously this has length 3. So the answer is what?
3 over 2.
3 over 2. Because this is the area of the parallelogram and the triangle has half the area. Right?